Welcome to Server Logic Simplified.
Have you ever noticed how the digital world around us constantly evolves, with software updates rolling out almost daily? Yet, somehow, despite all these changes, your favorite applications and services usually continue to function without a hitch. This seamless experience isn't by accident. It is a fundamental design principle at play, ensuring that the components of our interconnected digital infrastructure remains harmonious. The primary purpose of API backward compatibility is to ensure that older client applications can continue to interact successfully with newer versions of an application programming interface, or a PI, after the API itself has been updated. This means preventing breaking changes that would requiring all consuming clients to immediately update their code. In essence, it is about maintaining stability and preventing disruption across an ecosystem of interconnected software. At its core, an API acts as a contract between a service provider and its consumers. When a service provider updates its API, it is essentially revising the terms of that contract. Without backward compatibility, any change, no matter how small, could potentially invalidate the contracts for all existing clients. Imagine a major online retailer suddenly changing how its product search API works. Every mobile app, partner website, and internal tool that relies on that search function would instantly break, leading to a massive outage and significant financial loss. Backward compatibility safeguards against such scenarios by honoring previous contractual agreements. It allows API providers to innovate and evolve their services while giving consumers the time and flexibility to adapt to new versions at their own pace. Achieving backward compatibility largely comes down to thoughtful API design. Developers often implement strategies such as always adding new data fields rather than removing or renaming existing ones. Similarly, new parameters introduced to API endpoints should be made optional, so older clients that do not send them will still receive a valid response. When changes are absolutely necessary, a common practice is to introduce a new version of the API, allowing older versions to remain operational for an extended period, often with a clear deprecation schedule. This provides a migration path for consumers to update their systems gracefully. A critical tool in managing backward compatibility is semantic versioning, a system where version numbers like 1.0.0 indicate the nature of changes. A major version increment, like moving from version 1 to version 2, signals breaking changes and a lack of backward compatibility. Conversely, minor and patch versions denote new features or bug fixes that are backward compatible. Another advanced concept is graceful degradation, where an older client might not access a brand new feature but still functions correctly with the rest of the API, rather than completely failing. These practices underline a commitment to a stable and reliable API ecosystem. Ultimately, prioritizing API backward compatibility is an investment in stability, trust, and the long-term health of any software ecosystem. It reduces operational overhead by minimizing the need for constant, forced client updates. It also empowers developers to build more resilient applications, knowing that underlying services will not suddenly pull the rug out from under them. This foundational principle is what enables our complex digital world to grow and evolve continuously, without constant chaos, ensuring that software interactions remain dependable and seamless for everyone involved.
If this helps you code smarter, like, subscribe, and stay tuned for more.